once we understand what the outcome we're looking for and what question we're answering, and there's a multitude of questions to answer, that starts to drive the types of data sets we need. And then we work our way back in the chain to look at the actual data that's available. And once we understand that, now we start what amounts to be a refinement process. It's almost like pulling out the resource and now going through refining things as if it was a petroleum product or anything else you mine. It is now we have to actually make sure, where did the data come from? What's the veracity of the data? How do we know? When was it collected? And are we making sure that when we bring this data together, simple things like we're not comparing apples to oranges. We have the dates all aligned where they're similar. We make sure that all of the values are the same. It's an amazing thing. You would think that would be true always, but it's not. Some might be in milliliters, some might be in other measures. All those have to be mathematically normalized before we can actually normalize the data itself. And then we have to look at making sure that once we have those data sets, that they're actually giving us some reasonable expectation of the answer we want. And now, usually it's not true the first time through, almost never true. So now you're back looking at, how do we have to enhance this data? Are there different periods we need? Are there aggregations of the data we need to make to be able to enhance our ability to get a useful answer? And in the data science world, a lot of that is all about understanding, basically true positives, false positives, true negatives, false negatives. And what's our accuracy then of being able to make the proper prediction based upon that data we have? And oftentimes we find out that maybe we're only 48% accurate right now, and we need to keep coming back and looking at the data and possibly bringing in different data and different training sets to make sure that we're actually now reaching some threshold level of understanding we want. It's not a quick, and it's not an easy process. So we just don't pull data, put it in, and here's what it looks like. That's great for simple statistics, but not when it comes to actually making a predictive model at a threshold level of accuracy that we need to be useful in a case like this.
Yeah, and I think there are a good number of people out there that say, keep storing data, keep storing data, keep storing data, and they have all this data and they want to find a reason from an accounting standpoint to use it. What you're saying is that's the wrong way to do things. The right way is to start off with the goals and focus in on the data, and then get it better, refine it, correct it, normalize it, and make it work for you. Do you think, we'll get better at data because of this particular situation, or better at models?
Well, I think we have the possibility to become better at both. I mean, the more we exercise our abilities here, and the more we do problems, the more we'll learn, what type of data we need, what classes of data, and then what they call cohorts. Basically, that's simply demographics, particularly in how you're classified, and into what maybe your zip code and near your hospital. How we go through this tells us how efficiently we're actually coming to an answer. And the more we do that, the more we'll learn for the next time when we made pre-stage data, because we know from now they call the metadata standpoint what types of data we need and how we need those data pre-staged so that we can rapidly pull them into the process and then drive them into a model that will give us some level of understanding of the problem.
Yeah, so what I heard there is there may be a possibility to feed some of this back into the community to say, hey, look, we're over surge protected in this particular zip code and we're underserved in another one.
Oh, exactly. If this is a capacity problem, which is what we're being told, and the government is doing the right thing here by actually testing, people over 70 with a priority, because people under 20 seem not to get this very often. And under 9, there's no cases reported that I've seen. Now they're putting their resources on the highest mortality-driven types of cohorts and then backing their way through. And now we'll understand, once we've been through this And unfortunately, we won't have the data until we've been through it. And not just us, but the Italians, the South Koreans, worldwide will have a great database of experience with this that'll help us fully understand, at least as much as we can, what happened and then how to use that to build models to help us get through the next outbreak a lot better and a lot faster.